Hey everybody. Just really quick, wanted to make sure that if you were not solid with understanding the mole, that you would know what the mole is, and we can kind of go over that really quickly if you needed a refresher, because you do need to apply that to all the other stuff you do, right? So the mole is nothing tricky. It is just a like a ratio or a conversion, okay? Think of like 1 dozen is 12, right? We all know that. 1 dozen is 12, okay? It's exactly like the mole. So 1 mole of anything is 6.02 times 10 to the 23rd of anything, right? Like you could have 1 dozen donuts. That means you have 12 donuts. You could have a dozen pair of shoes. That means you have 12 shoes. You could have, I don't know, a dozen computers. Neat for you, okay, good job on however you're affording that. It means you have 12 computers, right? You could have 1 mole of burritos, okay? Yikes. You would have 6.02 times 10 to the 23rd burritos. You could have 1 mole of a substance, typically is what we talk about it in chemistry, right? You could have 1 mole of, I don't know, oxygen, 1 mole of carbon dioxide, whatever. It means you have 6.02 times 10 to the 23rd particles of that substance. So almost always we're using this number, which is Avogadro's number. Avogadro. Okay, avocado's number. We've all heard the jokes. Okay, all right. So you get this lovely number is 1 mole, all right? And then you just also use this kind of beautiful graphic, okay, to switch between mole and other things. So to go from mole to particle, you use the 1 mole is 6.02 times 10 to the 23rd conversion, okay? If I was going mole to mass, okay, you use molar mass to transfer. So molar mass, 1 mole of any substance is whatever its molar mass is in grams, okay? This is kind of, I don't know, not trickier, but just it's not the exact 6.02 times 10 to the 23rd. It's for anything, right? It could be for particles of carbon dioxide, particles of oxygen, particles of aluminum chloride, whatever. 1 mole of aluminum chloride is going to be a different amount of grams than a mole of O2. And you find molar mass. Hopefully we all know how to do this. This molar mass, right? Your molar mass of anything is just, you take the average atomic mass on your periodic table of all of those individual particles and you add it up. Okay, so like H2O, each hydrogen is 1.01. If you looked at your periodic table, right, the average atomic mass is 1.01. There's 2 of them in water, so this will be 2.02 plus my oxygen on my periodic table. You find it. It's going to be 16.00. So your molar mass of water is going to be 18.02 grams for 1 mole. That's how you convert between these two. And another thing you can do is volume only for a gas at STP, standard temperature and pressure, okay? And that is 22.4 liters, okay? So 1 mole, again, it's just, a mole is just a ratio. So 1 mole of any substance, any gas at STP, at standard temperature and pressure, is 22.4 liters. That's how much it takes up, okay? So you just use these wonderful conversions to go back and forth between figuring out how much of, you know, whatever substance you have. So if I started with 5 grams of a substance, I could figure out how many moles that is. If I started with 5 moles of a substance, I can figure out how many liters it is, whatever, okay? You just jump back and forth between these 3 things to convert between. Just in case. At least you have the conversion stuff.